So that was kind of a bummer. So I'm making sure that microphone is on today. All right, here we go. Day number 2. I hope that you got it started because this should tell you and show you, did you really capture a lot of what we talked about yesterday or not? All right. Daylin, can you please put your backpack down? Okay. So when I would simplify, what would I do here first? You tell me. Bless you.
2 times D.
2 times what?
D.
No, I want to pull those coefficients out, so I'm going to do 2 times 5 first. Okay. And then next I have d to the third. Whoops, I wanted a different color. D to the third and d to the second. So I'll write those down. D to the third times d to the second. So you're looking for things that have the same base. And then I have e to the second and e. What is the exponent on that e? It is a 1. It's 1 understood. Put a 1 on it. Ooh, 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 ooh. Don't put a ring on it. Put a 1 on it. And then finally, I have f. Put a 1 on it. Ooh, ooh, ooh. And f to the 5th. I forgot my e to the 1st. Okay. So right here, when I'm multiplying these all together, 2 times 5 is 10. D to the third times d squared. When you have the same base, what do I do with my exponents? Add them, yes. So this becomes d to the 5th. Here I have e to the second times e to the first. So that is e to the 2 plus 1, which is 3. And finally, f, I have the same base. I keep the base and add those exponents. 1 plus 5 is 6. How many had 10, d to the 5th, e to the 3rd, f to the 6th? Anyone? Raise them high, raise them high. Higher. You guys are like this. Your arms hurt? Okay. Any question about that? Daylin, I know you were not here yesterday. So if you have 2 powers, you keep the base, and they're being multiplied. You keep the base, you add the exponents. All right, number 2. This is scientific notation. Scientific notation. So here is my original decimal point. I need to change it so it's going to be a product of a number between 1 and 10 times a power of 10. Okay? Where am I going to put that decimal point? Between 7 and 3. Between the first 2 non-zero digits. So right away, I can go 7.3 times 10. You can do that right away. Now, to go from where I put that decimal point into my original, I go 1, 2, 3, 4, 5, 6 spaces to the left. Okay, to the left for you is going to be towards the smaller numbers and towards those that are negative. So that is going to be 10 to the negative 6. Anybody have 7.3 times 10 to the negative 6? 5. Eric, did you get this? 6. Okay. Remember, if you are going to the left, remember that is towards the negatives. So that's when you put the negative exponent. If you go to the right, it would be the positive exponent. All right? Any questions on either of those? I hope you got those written down. Let's go now to our notes. And we did not finish up with multiplication totally. There's scientific notation. Here, we got through power of a power. We got through page 4. We have a little bit left to do on page 5, and then we're going to do division. Division is what we're focused on today. This is a power of a product. Very similar to a power of a power that we did yesterday, but we have more things on the inside of the parentheses. So to find a power of a product, find the power of each factor. Each factor and multiply. So we're still multiplying, but we got to go through and see what the power is on each factor. For example, this is a negative here. Negative 5x squared times y, all of that is to the third power. That means every factor on the inside gets raised to the third power. Okay, and in case you've forgotten, if there's no exponent, put a 1 on it. Oh. Okay, so we have negative 5, and it's essentially you are multiplying everything. So 1 times 3 is negative 5 to the third power. And notice how they have negative 5 in parentheses. So if it's a negative, you really put it in parentheses. For x, it is 3 times 2, so that is x to the 6th. For y, it is 3 times 1. So that is y to the 3rd. So x to the 6th, y to the 3rd, those stay the same. And then on your calculators, you have to take negative 5 to the third power. Anytime you have a negative factor and it's raised to an exponent, you have to put it in parentheses. Okay? Negative factors. Write this down. Negative factors. So when you have things that you are multiplying, must be in parentheses. Because here's what you're going to do when you put it in your calculator. You might say, if you don't put it in parentheses, it's going to say negative 5 to the third power. Okay? If you remember your order of operations, we do parentheses first. Well, there's no parentheses here. Then we do exponents. So your calculator is going to say 5 to the third power. Well, in this case, it might work. 5 to the third power, and that would be 5 times 5 is 25, 125. And then take it times 1. Okay, so it actually kind of works this time. But sometimes when you don't, if I say 5 squared, okay, your calculator is going to say 5 squared, which is 25, and then it's going to say times a negative 1 is negative 25. But if you really are looking at negative 5 squared, we know negative 5 times negative 5 would give us a positive. So please put any negative factors in with parentheses, okay? Okay. All right, so here, let's go down to this example. Let me erase this gibberish down here. Letter A, power of a product. So everything inside here gets raised to the 5th power. Here, this does not have an exponent, so I'm going to put a 1 on it. This 5, it's like the distributive property, gets multiplied with everything. So this is going to be 3 to the 1 times 5 times x to the 5 times 5 times y to the 2 times 5. So that's 3 to the 5th, x to the 25th, and y to the 10th. Now, these are already simplified, but 3 to the 5th power is how much? I don't know. You guys have calculators, you would do 3 raised to the 5th power. 3 multiplied 5 times. 3 times 3 is 9. 81 times 3, 243. So it's 243 x to the 25th, y to the 10th. Questions on that? All right, let's take a look at B. This time, everything on the inside is multiplied to a power of 2. So my -5, I'm going to put a 1 on it. My A, I'm going to put a 1 on it. And my -5 out front, I'm going to put that in parentheses. So -5 to the 1 times 2 times A to the 1 times 2 and B to the 4 times 2. So this is -5 squared A squared times B to the 8th. -5 squared. -5 times -5 is how much? Positive 25, right? And then times A squared B to the 8th. There's your final answer. How many do not have a calculator with them right now? Just one? Why don't you guys go grab a calculator real quick? Or one of you bring like the whole set over with the handle. Let's go to the next one. Oh, we just decided not to label them, huh? You try this one on your own. 4x to the 3rd, y to the 2nd, everything inside there to the 3rd power. You try that one at your seat, okay? Just to make sure you can do this. I'll collect these from people who aren't here. Oh, you've done these. You feel pretty good about these? Feel pretty good about these? Good. Rihanna! Everybody should be trying this next one on your own. You feel pretty good about these too? You feel pretty good about these? Okay. All right. So again, if it doesn't have an exponent, put a 1 on it. It's understood to be to the 1st power. So this is 4 to the 1 times 3. This is x to the 3 times 3. And y squared times 3. So 4 to the 3rd, x to the 9th, y to the 6th. 4 to the 3rd is 64. X to the 9th, y to the 6th. How many had that for an answer? Tinder, how can I help you? Okay, think of this little exponent like you are distributing it. Everybody gets a 3, and when you distribute, you multiply. So that 3 gets multiplied times the 1. 3 gets multiplied by the 3 and by the 2, and then you just multiply those exponents together. And when it has a number here, then you can put that in the calculator. Okay? Do you know how to put exponents in the calculator? This would be like 4 and then the caret symbol 3. Right? All right, last one. Ooh, it's got a negative. So this is to the 1st power. Put a 1 on it. And here's a B, no exponent. Put a 1 on it. distribute, distribute, distribute. So negative 3 to the 1 times 6, a to the 3 times 6, and b to the 1 times 6 is negative 3. Ooh, I forgot to put my parentheses. To the 6th power, a to the 18th, b to the 6th. Can someone please put parentheses negative 3 and parentheses caret 6 and tell me what you get? Should be what? 243 times 3? Anybody get 729? Okay. 729, a to the 18th power, b to the 6th. Any questions on the multiplication? All right, let's turn the page. Page 6. Division. Division is just like repeated subtraction. Okay? Quotient of powers. Quotient means the answer to a division problem. Answer to a division problem. All right, you can use repeated multiplication and the principles for reducing fractions to simplify quotients of monomials with the same base. They still have to have that same base. Like 2 to the 8th divided by 2 to the 3rd. First, expand the numerator and the denominator, then divide the common factors. So here they're showing you 2 to the 8th power means 2 times 2 times 2, 8 times. 2 to the 3rd power is 2 times 2 times 2, 3 times. And if you notice, everything, especially if your denominator is smaller, those cancel out, and you're left with 2 times 2 times 2 times 2 times 2, which is 2 to the 5th power. Okay? If you started with 8 and the bottom has 3, one way to do that is to actually subtract and say 2 to the 8 minus 3 is 2 to the 5th. So for multiplication with same bases, we add the exponents. For division with same bases in your powers, you are going to subtract. So here we have r to the 5th divided by r to the 4th. We know if we write it all out that 4 of these are going to cancel out, and we're left with just that r. But if we have r to the 5th divided by r to the 4th, they have the same base. You keep the base and you subtract the exponents. You take the top exponent minus the bottom exponent, and that gives you r to the 1st or just r. Okay? So the concept is to divide two powers with the same base. The key is, again, they have to have the same base. Subtract the exponents. And they go through examples here. La-di-da-di-da. Okay. So let's do this problem here. Simplify b to the 5th, c to the 7th, divided by b squared c. And we have to assume the denominator does not equal 0 because you cannot divide by 0. So we will assume that. So I'm going to rewrite this as b to the 5th, c to the 7th, divided by b to the 2nd, c, and there's no exponent on there. So what do? Nobody's going to do that for me, Rihanna? Put a 1 on it. Oh. I would die if somebody did that in class. So here I have b to the 5th divided by b to the 2nd. That is b to the 5 minus 2 times, because we are still multiplying in between the factors. Tinder. The answer is not on the ceiling. Okay, let me help you. Try to stay here. C to the 7th. And we are dividing by that same base of C, so I am going to subtract the exponents. So if I simplify this, I get B to the 3rd times C to the 6th. And that is your final answer. Okay, help me understand. Did you understand the multiplication yesterday?
On the testing.
Ah, okay. Might have to look back in yesterday's notes on Canvas. Okay. All right, let's turn to. I'm just looking. So we got 2 pages, not a lot of time. Okay, so let's simplify a few of these. Let's do letter A. So we have A squared, B to the 9th, C, D to the 4th. Anywhere you see that there is no exponent, I would put a 1 on it. Okay? Put that 1 inside. Now, A squared does not have an A below it. So we're just going to keep that as A squared. Okay? B to the 9th divided by B to the 8th. You're going to keep the B and subtract the exponents. Okay? Because we are dividing 9 minus 8. You're going to subtract the exponents. Let's look at my C's. I have C to the 1st divided by C to the 1st. That is C to the 1 minus 1. And finally, I have D to the 4th and D to the 3rd. That is D to the 4 minus 3. They have the same base. You keep the base and subtract when you are dividing those powers. So let's simplify. A squared just stays as A squared. B to the 9 minus 8 is B to the 1st. And if you don't want to put the 1 on there, you don't have to. C to the 0 power. And finally, we have D to the 1st power. All right, this C to the 0 power, I thought maybe this would come up earlier, but if you have any value to the 0 power, it is actually equal to 1. So this is just like multiplying a 1. So I have A squared, B to the 1st, times 1 times D to the 1st. Anything times 1 keeps it the same. Final answer is A squared, B to the 1st, D to the 1st. So anything to the 0 power is 1. You'd think it'd be 0, but it's not. Any questions on that? All right, let's take a look at B. So I look at my coefficients. I have a 2 and an 8. So I just write those out in fraction form for now. So 2 divided by 8. I have an x to the 4th and an x to the 9th. So this is going to be times x. You take the top one, which is 4, minus 9. Okay? Then I have a y to the 3rd. There is nothing on the bottom, so I just keep it as y to the 3rd. And then finally, I have z to the 5th divided by z to the 8th. So that is z to the 5 minus 8. All right, let's simplify this a little bit. This is a fraction. This is not 8 divided by 2. It is 2 divided by 8. What number divides into both of those that I can simplify? 2. So if I divide by 2 over 2, because that's really 1, I'm not changing the answer, I'm just simplifying it. That's going to give me 1/4. X to the 4 minus 9 is going to be x to the negative 5 power. And y to the 3rd stays the same. And z to the 5 minus 8 is going to be z to the negative 3rd power. Now, if you look in any of these, we don't really have any negative exponents. And when you are simplifying, you do not want any negative exponents. Okay? Kathy, you hear me? No negative exponents. So what this does, when you have a negative exponent, it says, I'm not going to stay in the numerator. I am going to move down to the denominator. So here's what it looks like. We have 1/4. X to the negative 5th is going to go down to the denominator and become x to the 5th in the basement, in the denominator. Okay, guys, this is really important. X to the negative 5th moves down. Okay, y to the 3rd, that one's okay. So he's going to stay on top. And z to the negative 3rd power, again, negative exponents, you can't have it. He's going to move down to the bottom bunk. Think of it that way. And that becomes z to the 3rd. So my final answer, if I simplify all this, 1 times y to the 3rd is y to the 3rd, all divided by 4 x to the 5th, z to the 3rd. Now that was kind of a lot for that particular problem. Okay? Any questions on that? So I had the 2/8. I simplified that fraction. When I'm dividing powers and they have the same base, you subtract the exponents. If you have a negative exponent, you move it from wherever it is. If it was in the top part, you move it to the bottom. If you end up having a negative exponent in the denominator, which we haven't had yet, then it's going to move to the top. So there is a lot going on here. All right, let's go to C. Everybody wake up. Should we do some jumping jacks? Jumping jacks? 1, 2. Don't you like how I'm jumping? All right. Here we go. Let's look at C.
You didn't rate me?
No.
Who coached you?
No. They just gave me this shirt when I came to Pike.
Oh.
It was an extra. All right, here we go. So this is negative. That -1, okay? I'm going to put that -1 out front. I have a 3 to the 1st power. So I'm going to put the 3 there. There's nothing on the bottom. I have h to the 4th divided by h to the 4th. So we could do h, because you keep the base, and you subtract the exponents. Girls, come on, come on. Then I've got j to the 3rd divided by j to the 2nd. You keep that base and you subtract the exponents. And finally, we have k to the 3rd divided by k to the 3rd. You keep the base, subtract the exponents. So I have changed this all now so I can simplify it. -1 goes out front. 3 is going to stay there. H to the 4 minus 4 is h to the 0. J to the 3 minus 2 is j to the first. And k to the 3 minus 3 is k to the 0. What is anything to the 0 power again? 1. So this is a 1. This is a 1 that we multiply. Here's j to the first. Here's 3. Here's negative 1. Well, anything times 1, that's just anything. Negative 1 times 3 is negative 3 j to the first. So all of that simplified down to negative 3j to the first. And that's what we're doing. These aren't equations. We're not solving. We're just simplifying. All right? Let's do D. Okay? So we have the negative out front. Negative 1. I have a 4, and I have a 4 in the bottom. So that is 4 divided by 4. I have an x to the third power. There is an x back here. X to the squared. So that is x to the, you keep the same base and subtract because we are dividing them. Then I have y to the third and a y. I got to put a 1 on it. So that is y to the 3 minus 1. And back over at the end, I have z squared. That's all there is for that one. Okay, so I'm going to keep that negative 1. What is 4 divided by 4? 1. So that's just a 1. So I can put times 1. X to the 3 minus 2 is x to the first. Y to the 3 minus 1 is y squared. And z squared, that's the only one there. Negative 1 times 1 is negative 1. X to the first, y squared, z squared. Final answer. Nice! Okay. All right. One more thing to go over. Power of a quotient. Okay? Power of a quotient. Similar to what we just did. So, a quotient, we're talking about something that looks like a fraction. Okay? Like 2/5 to the third power. What does that mean? It means 2/5 times 2/5 times 2/5. And if you break it down, that's 2 times 2 times 2, which is 2 to the third, divided by 5 times 5 times 5, which is 5 to the third. So this 3 goes with the top and the bottom. Okay? So it's 2 to the third divided by 5 to the third. If we have P divided by Q, all to the second power. Okay, this means that whole thing is multiplied twice. P times P is P squared. Q times Q is Q squared. So it's taking this 2 to both the top and the bottom. All right. So this to find the power of a quotient, find the power of the numerator and the power of the denominator. Okay, so example 3. Again, if you see something, you don't have an exponent on it, put a 1 on it. So this is page, what page is this? 8? Okay, page 8. Jada, are you with me? Jada, page 8. So 5 to the first, a squared, all divided by 6 to the first power. This is just like that distributive property again, okay? You are going to distribute the 3 with every power on the inside. So this is 5 to the 1 times 3 times a to the 2 times 3, all divided by 6 to the 1 times 3. So that is 5 to the 3rd, a to the 6th, all divided by 6 to the 3rd. Now, anytime you have a number to a power, you can simplify those. 5 to the 3rd power is, if you take 5 caret, it's a V, right? 3 is going to be 125, a to the 6th, all divided by 6 to the 3rd power. Can somebody tell me that? Oh, it goes up, doesn't it? 6 to the 3rd power is 36 times 6, 18, 19, 20, 21, over 216. And that is your final answer. Power of a quotient. Okay. Let's do one more. Good morning. Who's that for? Me. Is it for me? Oh, I have him next period. If he's here. What if he's not here? Okay. Okay. All right, here we go. Simplifying. This is power of a quotient. If there is no 1 on anything as an exponent, put a 1 on it. This 4 gets multiplied with every exponent. It's almost going to look like a spider. Okay? So, this is going to be 5 to the 1 times 4 times j to the 3 times 4 time, is that J or I? Oh, that's an L. Rihanna. L to the 2 times 4, all divided by 7 in the denominator to the 1 times 4, and k to the 5th times 4. So then we're just simplifying. 5 to the 4th, j to the 12th, l to the 8th, divided by 7 to the 4th, k to the 9th. These are numbers. Numbers to a power we can simplify. What is 5 to the 4th power? What is it? I thought somebody said something. 625, I believe. J to the 12th, L to the 8th. All divided by, I need help with 7 to the 4th. I do not know what that is. What'd you get? 2,401. And k to the 9th. I don't have anything on the top and the bottom that are the same, so that is your final answer. Okay? All right, listen carefully. Your homework, which is due on Monday, is the last page in your packet. Okay, I think it says homework 1 and 2, front and back. That is due on Monday. Okay? So all you will need to do is just rip it off if you get it done on Monday, and you can hand it to me. Okay? All right. Please look back in your notes. I also have some videos that are not here from the class. Use those to help you with